Hello, my name is Huanon Pongshalam from class 612, number 22.
Hello, my name is Kitapat Slit from class 612, number 16.
So, hello, my name is Shepo Narendran Naitaya, number 14 from class 612. Today, we will be exploring about two groundbreaking experiments. First off with the Compton effect and the double slit experiment. These experiments revolutionized our understanding of light and matter, introducing the fascinating concept of the wave-particle duality. So let's dive in. So to start off, physics isn't just about the formulas and calculations. It's about the understanding of the universe at its most fundamental level. The Compton effect and the double slit experiment are the keys to unlocking the mysteries of the quantum mechanics. They show us how the light and matter behave in the way that we defy our everyday experience, challenging what we thought we knew about in reality.
Let's start with the Compton effect, discovered by Arthur Compton in 1923. In this experiment, high-energy X-rays were directed at a target made of graphite. Compton observed that after the X-ray collided with electrons in the graphite, the scattered X-rays had a longer wavelength than the original ones. This shift in wavelength, called the Compton shift, occurs because the X-rays transfers some of their energy to the electrons, causing the electrons to recoil and gain kinetic energy. These experiments showed that light behaves like a particle because the collision between the photon, which is light particle, and the electron resembled an elastic collision in classical physics. Key takeaways: the wavelength of X-rays increases after the collision. The scattered electron gains kinetic energy. This suggests that light has momentum, behaving like a particle. The Compton effect provided strong evidence that light isn't just a wave, it also has particle-like properties. Thank you.
So next, let's talk about the double slit experiment, which originally done with light, but laser is adapted for electrons, by Clinton, Davidson, and Lesser Germer. In this experiment, electrons are fired at a barrel with two slits, and behind the barrel was a detection screen. But surprisingly, instead of forming two distinct bands like particle would, the electrons create an inference pattern, just like when waves do when they overlapping each other.
Hello, my name is Jamed from class 612, number 13. Now let's talk about double slit, beginning with a diffraction first. Diffraction is a bending of wave around corner through slit. And okay, let's talk about double slit. Double slit, a light pass through slit, and then we have a three formula for it, but the most common one is a m lambda equal dx over L. What is it for a letter? The first one is a lambda. Lambda is a wavelength. D is stand for a distance between two slits, and x is a distance between maximum point and minimum point. I will mention a maximum point and minimum point later. And last one is L over L is a distance between slit to the skin. Okay, what is x for a maximum point, minimum point? Minimum point is a dark fringe, is a destructive interference. That means you cannot see the light. For the next one is a maximum point is a bright fringe, is a constructive interference. You can see the light. Okay, the another two formula behind it is a m lambda equal path difference, or p1 minus p2, and here, and other one is a m lambda equal d sine theta. As I mentioned before, what is d? This is a distance between two slits. And okay, then Later, the originally is a white, but later they adapt for electron by Compton Davis and Lester Germer, as you can see it here. And you can compare two of it. In this segment, electrons were fired into a barrier with two slits, and behind the barrier was a detection screen. As you can see, it very similar to each other, in the same pattern here. But what difference is a electron beam gun? It's a key one because they are changing from a light to electron. So electron can move to a slit. Instead of forming two distinct bands like particle would, the electron create an interference pattern just like a wave do when they overlap. This pattern shows that electrons exhibit wave-like behavior even though they are particles. However, when scientists place a detector to observe which slit the electron pass through, the interference pattern disappears and electrons behave like regular particle again. This experiment proves that not just light, but even matter like electron can behave both as particle and wave. Thank you.
So, what does all of this mean? These experiments led to the concept of wave-particle duality, and this means that all quantum objects like light and electrons and so on can exhibit both wave-like and particle-like properties, depending on how they are observed. And the de Broglie hypothesis proposed by Louis de Broglie, suggesting that particles like electrons have wavelengths associated with them called the de Broglie wavelength. And Copenhagen interpretation suggests that quantum particles exist all possible states until observed, collapsing into one state upon measurement. And wave-particle duality is a cornerstone of quantum mechanics, changing how we understand the universe at the quite smallest scale.
So in summary, the Compton effect shows us the particle nature of light, while the double-slit experiment revealed the wave-like behavior of electrons. These experiments prove that the both of light and matter can behave as particle and wave, depending on how we observe them. And this dual nature challenges the classical physics and form the foundations of modern quantum mechanics. Understanding these principles help us to unlock technologies like lasers, semiconductors, or even quantum computers. Thank you for watching.